Hello, let's start solving an integral and derive an interesting result from it. Given I is integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 by a plus bx whole power m plus n dx. So let's start. As you can see in the numerator, uh, it is x and 1 minus x terms, right? So let's make a substitution here. Let's consider t as x by 1 minus x, right? Now then this will be 1 by t equal to 1 minus x by x, which is 1 by t equal to 1 by x minus 1. So this will become 1 by x equal to 1 by t plus 1, which is 1 plus t by t. That implies x equal to t by 1 plus t. Fine, just remember this result as we are substituting, and we need to find a dx value, right? How will we find dx? This here 1 by t is 1 by t is 1 by x minus 1. So now if we differentiate this will be 1 by minus 1 by t square dt equal to minus 1 by x square dx. Differentiation of 1 is 0. So this will go off. Then dx is x square by t square into dt. But we know what x square is. So dx is 1 by t square into x square value is t square by 1 plus t whole square dt, right? So t square will get cancelled, and you will get dx equal to dt by 1 plus t whole square. Fine. Now let's figure out the integration limits, right? When x equal to 0, when x equal to 0, if x equal to 0, then t becomes 0, right? When x equal to 1, when x equal to 1, as you can see here, when x equal to 1, it will become 0 by 1. If then t will be 1 by 0, which is infinity, right? Then if x equal to 1, that implies t tends to infinity. Then let's write I value here, integral 0 to infinity x power m minus 1. What is x? T by 1 plus t. T by 1 plus t whole power m minus 1 into 1 minus x whole power n minus 1. 1 minus x which is t by 1 plus t whole power n minus 1 in by a plus bx, right? Which is, write it down, a plus b into x. X is t by 1 plus t, right? Whole power m plus n into dx, which is dt by 1 plus t whole square, right? So let's simplify it step by step. Then this will be integral 0 to infinity. This will be t power m minus 1 by 1 plus t whole power m minus 1. Now this is 1 plus t minus t by 1 plus t, right? So this tt will get cancelled, and you are left with 1 by 1 plus t whole power n minus 1 into this will be as it is. Let us write it down. Now this denominator part, this will be a plus at plus bt by 1 plus t whole power m plus n whole power m plus n. So let's simplify it further. Then this will be I equal to integral 0 to infinity, right, t power m minus 1. As you can see, there are relations here about 1 plus t. There are many things there. Let's write it down first. By 1 plus t whole power m plus n, 1 plus t m plus n minus 2. Fine. Then this comes in the numerator, which is 1 plus t whole power m plus n into dt by 1 plus t whole square by here let's take t as common here. Then this will be a plus b whole power m plus n. Then I becomes integral 0 to infinity. As you can see, this will be, these whole terms will get cancelled. As you can see, this can be written as 1 plus t whole power m plus n into 1 plus t whole power minus 2. This m plus n will get cancelled, and these two will get cancelled with this part, right? Then we are left with t power m minus 1 by a plus t into a plus b whole power m plus n into dt, right? We need to simplify it further. Let's make some substitutions. Let's consider this t into a plus b as a into tan square theta, right? It will be easier now. Now this will be, if you take a as common here, a into t 1 plus b by a equal to a tan square theta. Now a will get cancelled. Now t is tan square theta by 1 plus b by a. Let's figure out dt. Then dt is 1 by 1 plus b by a is constant, and this is 2 tan theta differentiation secant square theta d theta. Fine. Then if, let's figure out the integration limits. If t equal to 0, then if t equal to 0, theta will be 0 because tan 0 is 0. If t is infinity, theta must be pi by 2, right? Because tan pi by 2 is infinity. Now the integration limit changes as integral 0 to pi by 2 t power m minus 1. Here t is tan square theta by 1 plus b by a, right? Then this is tan m minus 1, right? Square into m minus 1, which is 2m minus 2. Tan power 2m minus 2 theta by 1 plus b by a whole power m minus 1. Fine. By, we have written a t into a plus b is a tan square theta. A tan square theta, right? This will be a tan square theta. If you take a as common, then it will be 1 plus tan square theta, which is secant square theta. Then you can write a secant square theta into m plus n. Then we are left with dt. dt is 2 by 1 plus b by a into tan theta into secant square theta into d theta. Fine. Now let's simplify this. This is integral 0 to pi by 2, right? Before writing this, let's keep all the constants out, so it will be easier. Here it's 2 by 1 plus b by a. As you can see here, this is 1 plus b by a into m minus 1 into 1 plus b by a, which is m minus 1 plus 1, which will be 1 plus b by a whole power m, right? This constant's gone, and this constant, which is a into a power m plus n into 0 to pi by 2, right? Tan power, this is tan power 2m minus 2 and tan theta. Minus 2 plus 1 is minus 1, which is tan power 2m minus 1 theta by, this is secant power 2m plus 2m, secant power 2m plus 2n. There is one more secant theta in the numerator, so when it comes in the denominator, this will be minus 2. Fine. Then this is d theta. So finally I is 2 by, let's do some simplification here. This will be a plus b whole power m by a power m, which will be in the numerator. Then this a power m plus m can be written as a power m into a power n. So a power m will get cancelled. Then this is 0 to pi by 2. Now this can be written as tan power 2m minus 1 theta can be written as sine power 2m minus 1 theta by cos power 2m minus 1 theta, right? When it comes in the numerator, this will be cos power 1 minus 2m, right? Then this is 1 by secant is cos power 2m plus 2n minus 2 d theta. Fine. Here I is 2 by a power n into a plus b whole power m into 0 to pi by 2 sine power 2m minus 1. Sorry, there are thetas, right? All the thetas. Sine power 2m minus 1 theta. Now as you can see, this 2m will get cancelled, and you are left with cos power 2n 1 minus 2, which is minus 1 theta d theta. Now as you can see, this is related to beta function, which is I equal to 2 by a power n into a plus b whole power m into half of beta function of m comma n. Fine. Now these two will get cancelled. Now this I is 1 by a power n into a plus b whole power m into beta function of m comma n. So this is integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 by a plus bx whole power m plus n dx is beta function of m comma n by a power n into a plus b whole power m, right? I mean, you can write it in the other form as, if let's consider a plus b as c, then b is c minus a, right? Then this can be written as integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 by a plus, here b is c minus a, right? C minus a into x whole power m plus n dx is beta function of m comma n by a power n into c power m, right? This is this result.